Hello guys, welcome back. In this video we're going to talk about covariance and correlation. Before I start with covariance, let us first revise what variance is. So as you know, variance is the average of square distance from the mean, right? Variance is denoted by sigma square and it is average of squared distance from mean. Or we have studied this variance and measure of spread. That means the variance also denotes how spread the data is, right? The formula for variance is total number of samples, where mu x is the mean of the data, x is the instance element squared. So now what is covariance? Covariance is the variance between two attributes. Like here we have sigma square of x is this. If I say I need something like covariance or variance between two attributes, what are those two attributes? X and y. How will the formula be look like? It would be like x minus mu x, x minus mu y divided by n. We have broke down the variance formula to derive the formula for covariance, which is nothing but just the joint variability of two variables. How one attribute or one variable varies with another. Let's see, if this term here x minus mu x is negative and this term x minus mu y is positive, what will be the overall covariance? Will it be positive or negative? It will be negative, right? Because a negative multiplied by positive is equals to negative. Similarly, if it is negative, this term will come out to be negative and this term also will come out to be negative. The whole thing goes positive. That means if both things are negative, the whole thing becomes positive. I will just explain this thing with an example here. So let's say this is the x that we have taken and this is y. Okay, and now if I plot some elements, something like this, so what do you get from this graph? We get that okay, this graph is an increasing trend like this, right? That means when x is increasing, y is also increasing. In this scenario it is positive, it is also positive, and this becomes positive, right? Now let's look at another thing. This is x, this is y, and their relation between each other, if I plot it into an xy plane, is like this. So when x is decreasing, you can see y is increasing, right? When x is decreasing, when x is on a negative mode and y is increasing, this becomes, whole thing becomes negative, and we can see that it is a downtrend, right? There's a negative covariance between these two attributes. So this is a general idea of how covariance works, and we will also see this covariance with respect to some real data. But before that, let us also introduce what is correlation. You can say covariance is not a very high standard of measure of joint variability. Let's say we have covariance x and y is 25 and covariance of, let's say, a comma b is 75. Though this covariance of A comma B between A and B is greater than covariance of X and Y, but we cannot conclude from here that A and B varies more positively with each other. Now that covariance does not guarantee how two pairs are related, we have correlation. So in correlation, it also gives you the measure of how strongly two variables are related to each other, and correlation is between -1 to +1. Okay, formula for correlation is, if you want to check the correlation between X and Y, then it will be covariance of X comma Y divided by variance of X, variance of Y to the square root. This is the correlation. Correlation is used in many things when we start working on data, but for now, if you want to imagine a fact, let's say if two features we have, two attributes, height and weight, I can probably say that yes, if a person is tall, his weight would probably be larger than the shorter person, right? That means this height and weight are related to each other. If height increases, weight also increases. If you want to check the measure of their relatedness, how strongly they are related, then we must apply correlation. We must calculate the correlation between height and weight. We will see these things in practical with data. So see you in the next video.